Hi, welcome back. I am Nisha. In this session, we are going to talk about how to search a particular value from an integer array. Array means it's a collection of values. So from that group, we can search a particular item and we can print the position of that particular item. So how we can do that? Mainly two methods are there. One is linear search and the other one is binary search. So here today we can study about linear search. Okay, so let's see. Okay, what is linear search? First, we want to study the method of that linear search. What is that? So it is using for searching only, but why we are putting linear? What is the meaning of that linear here? Okay, just see the points. Declare a variable for search element. So first, just assume that integer array is already there with some elements, some values. Okay, here we are declaring a variable for the search element. So we need a variable for inputting the which we want to search it. Then accept the search element in that variable. So we are accepting a value to that search variable. Then next is what? We want to check that value is there in the array or not. So array group of values are there, is it? So we want to check it from the first element onwards. So how we can check that? Yeah, use loop. We need a loop for that one. So why we are using loop? See, loop for searching starting from the first element until the desired one is found. Because collection of values are there. So we want to check it from the first position onwards until the desired one is found or the end of the list is reached. Okay, so here we are searching through a loop from the first element to the end of the array. So if we found that value, we can print the position of the search element. This is called linear search. Linear, sequential way. One by one, we are moving and checking. Is that search value is there in the array or not? Is it in the first position? Is it in the second position? Is it in the third position? Like that, we'll move on checking from the first onwards. If we found it, we can print the position of that element. That is called linear search, or we can say sequential search. So let's see the example here. See, this is the array. The values are here and see 0 to 10 element 9 index number. We stored the values, so 10 elements are there in the array. Now we want to search an element. Search item is 34. So 34 I want to search it. So just see 34 is it in the first position? No. Is it in the second position? No. Is it in the third? Is it in the fourth? Is it in the fifth? Yeah. Is it in the sixth? We got the sixth position. Is it? So we want to print that it is in the sixth position. See, 34 is found at the position number 6. So this is called linear search. Okay, now we can see the algorithm, how we can write the program in stepwise. Before get into C++, first we can study how we can write the algorithm of that. Okay, let's see. So here we can see the algorithm of linear search. Algorithm means the stepwise order for finding that particular item by using linear search method. Okay, see the first point. Step 1 start. Step 2 accept a value in n. Here n is a variable name. Accept a value in n as the number of elements of the array. So array we can declare with the maximum size. But how much you need? So that we can input in n. So here n is deciding the size of that array. Then as step 3 is accept n elements. So n inside that n variable there is a number, so that will decide the size. So accept n elements. So that much elements we want to input in that array. So accept n elements into the array ARR. So here the array name is ARR. So accept n elements. If for example 10 is assigned in n means we want to input 10 numbers in that array. If it is 5 elements we want to input it. Understood? Okay, now array declaration over and the values are there now. Now in step 4, accept the value to be searched in the variable item. So here one more variable we use, that is item. in this item we are inputting the value to search which item we want to search, that value we are inputting in the item variable. And one more variable, see step 5, set location LOC, one variable declared, and we are assigning as -1. LOC is equal to -1. That means now the location value is -1, -1. It is less than 0. So the array index number, the position number starts from 0 onwards. Is it? So less than 0 means the location is null now. Nothing is there. It's not pointing anything. That is -1, less than 0. So we want to find out the location where the element is. So step 6, starting from the first position, repeat step 7 until the last element. Until the last element. See, this step 7 we want to repeat it from the first position onwards until the last element. So from the 0th position onwards we want to do that step 7. So what is there in that step 7? Just see. Check whether the value in item is found in the current position. Check whether the value in item is found in the current position means now we are at the starting position, 0th position. Is that value is equal to 0th position value? Check whether the value in item, so that item is equal to the current position. Current position means is it in the 0th position? So if found, then store the position in location, LOC variable. So first we declared with -1. So if we got the item, then we can store that position in LOC variable. And go to step 8. We got the element and we assign the position in LOC variable and go to step 8. What is there in step 8? If the value of LOC is less than 0, in the step 8 we put if the value of LOC is less than 0, that means if it is -1 itself, then display not found. Else, otherwise, if it is not -1, else display the value of location +1 as the position of the search value. Location +1. Why we are putting +1? Because in that location we will get the index number. It's not position number. So index number is starting from the 0th position onwards. But by viewing that, we can say first element, second element, third element like that. But the index number is from 0th onwards. So at the printing time, we want to show the position, not the index number. So what is the value in that location? That is one index number. So that +1 is the position of that value. Okay. So if we found, then store the position in that location and go to step 8. Else move to the next position. Okay. So here what we are doing in the step 7. Step 7, item. That item variable is equal to that 0th element. If it is okay, then we can find the position of that one and we can store it in the LOC variable. If it is not, we can move on to the 1, index number 1 position, and we can check that one. Is that value is equal to item? If it is okay, we can put that 1 as the location. If it is not, we can move to the next one. Then the third position. Then third position value, is it equal to item? If it is okay, we can store the index number in LOC variable. If it is not, again we want to move on to the next location. So this is the step 7. So this step 7 we want to repeat it until the last element. If we didn't found that value, we want to keep on moving until the last element. Okay. So this is the algorithm, and in last step is stop. So if we got the element, we can print location +1. We didn't got the element means the location is -1 itself. So we can display that the item is not found. So this is the algorithm for linear search. Understood? So one more time I will explain. Accept a value in n. N is the variable for inputting the size for that array. So accept a value in n as the number of elements of the array. Accept n elements into the array ARR. So the third step is accept n elements. So n is the size here. How many numbers you need in an array? So that n will decide. So accept that much element into that array ARR. Then next is, after inputting all the elements in the array, next step is we want to input the value for search. Where we will input that value? It's in the item variable. So here I put item as the variable using for search element. Then one more variable I declared, set LOC is equal to -1 location. So LOC is the variable used for that. That is equal to -1 means we didn't found anything. So first initial value is less than 0. 0th onwards the index number will start. So we can put the location is now -1. That means it is less than 0. Then step 6. Starting from the first position onwards, we want to repeat the step 7 step. Okay, until the last element. We want to start from the first position onwards until the last element. But at the moving time, we want to repeat the step 7. What is there in the step 7? Check whether the value in item is found in the current position. If the current position is 0 means, is that element, is it equal to item? If it is okay, we can store that value position on the LOC variable. If it is not, we can move on to the next location. Then we can check it with item. Is it equal to this one? If it is okay, we can find the location and we can assign that value in a LOC variable. And if it is not, we can move on to the next one. So we can keep on moving. If the item is not found, we can keep on moving until the last element. Okay, now see what is there in the step 8. If the value, we got the element means the LOC value is changed now. So it is not less than 0. If it is not found means the value is still in -1 itself. That means that time we can print it is not found. That is the step here. If the value of LOC is less than 0, then display it is not found. Else, that means it is not less than 0. It is not in -1 position. We got the location here. So we can display the location. So in LOC, it's an index number. Index number starts from 0th onwards. But position means we can say first element, second element, third element. So that is the difference in position and the index. Okay, index is -1 of position. So here we want to print the position. So LOC is the index number. LOC plus 1, we will get the position of that search value. Got it? This is the algorithm for linear search. Now we can check how we can write the C++ program. Okay, let's see. Okay, C++ program for the linear search method. First, int main for the beginner. Then int AR of 10, comma n. So AR is the array here and 10 is the maximum size. And one more variable declared n. This n is using for how many elements you need. Okay. So next is int I for index number, item, one more variable that is for search element. Then location is equal to -1, location for finding the location. And first we initialized it with the -1. That means no value because 0, from the 0th onwards, index number starts. So 0 less than 0 means we didn't find anything. So that is the meaning of location is equal to -1. Then next is we want to give a message, means prompt for how many elements you need for the array. So we want to input it, see in n. So n will decide how many elements we need in that array. So we want to input inside that array. So how we can input? From the 0th position onwards we want to input it. So we need a loop for that. So enter the array elements. We give a prompt there for inputting. Then see for loop I is equal to 0. 0th onwards we want to start it. I less than n. 10 is the maximum size, but only n values we need. So we can put I less than n. Then I plus plus. So first I is equal to 0. Second time I 1, 2, 3 like that it will go on. So when it is in 0th position we want to input it. So C in AR of I. So the first element will input in the 0th position. Then I plus plus, I will become 1. Then I less than n checking. If it is true, again Cn for the second element. So this will continue. We will get n elements there in the array. So after inputting, we want to search a particular element. So which element you want to search it? So enter the item you are searching for. So we are giving a prompt for that one. Now we want to input a value in that item for searching. So here C in item. So we already input. Now the next step is what? We want to check that item is there in the array or not. So how we can check that? From the 0th position onwards, we want to check it. That is linear search. So how we can check it? Yeah, we need to use the loop. Same like I is equal to 0th onwards. Is it? I is equal to 0, I less than n until the elements n. Till that one we want to check it. Okay. So how we can check it? We want to use an if for checking. If AR of I means AR of I means I is equal to 0 now. So if AR of 0, is it equal to item? So we are comparing the values. Is it equal? AR of I means the 0th position element. Is it equal to item value? If it is equal, we can say that location is equal to I. So that index number we can assign in that location. Then we don't want to move it, is it? So we can break. So if we found the value, we can set the index number to the location and we can break from the loop. So when you use break means we can exit from the loop. But if the condition is false means it will directly move to I plus plus because there is no else portion. So I plus plus. So it will move to the second element. Is it? Then second element, is it equal to item? If it is not, then the third element, then the fourth element, then the fifth element. So we will reach on nth location. Is it less than n? We put there I less than n. So at the end of the element we will reach it. We didn't found that value. So what to do? We didn't get the location. Is it? So now we want to check it. Is the location value is minus 1 or I? So which value is there in the location? So we want to check it. Now we can see if location not equal to minus 1, not equal to, see the operator, not equal to minus 1 means some value, some index number, we got it in the location. So that time we can print, see out the item, the input value is found at the position location plus 1. So location is I now, index number. So the position is plus 1. So we can print it location plus 1. But location is equal to minus 1, then what to do? So else. So see out, if it is else, the item is not found in the array. If the location is equal to minus 1 means the item is not found. So we want to print it that message also. So the item is not found in the array. Now the program is empty. This is called linear search. Okay. So first we declare the array and we declared one item variable for the search element and we set the location as minus 1 first. Is it? Then after inputting all the elements, we are searching that element is there in the array or not. So AR of I is equal to item. This is the way of comparison, sequential search. From the 0th position onwards we are searching until the end of the element. That is I less than n. We got the element, we can set the location as I, that index number, and we can break it. We can exit from that loop. If we didn't get means the I value is now n. Is it? Yeah. Now we can check it. We got any value in location or not, or is it minus 1 itself? So how we can check it? If location is not equal to minus 1, the item is at the position location plus 1. Else the item is not found in the array. So it is very simple, right? This is called linear search. Now we can see the example here. See, this is the array. 10 is the maximum size. But here we input only 8 items. See, 1, 2, 3, 4, 5, 6, 7, 8 elements are there. Okay. Now location is equal to minus 1. and the item I want to search it as 34. So how we can search it? From the 0th position onwards, we want to search it. 10 is equal to 34 or not? See, it is checking. 10 is equal to 34 or not? It is not. So, the location is -1 itself. So, 34 is equal to 7? No, it is not. So, we want to move to the next element. Is it 12? No. Then we are moving to the next element. Is it 18? No. Then we want to move to the next element. Is it 3? No, it is not. So the next element. Is it equal to 34? Yeah, 34 is equal to 34 now. Is it? Now the value of location is what? See, the value changed to 5. See, 5 is the index number. 0, 1, 2, 3, 4, 5 is the index number here. But see the position of values. First element, second element, third element, fourth element, fifth element, and sixth element. So we want to print it as the position of that value is 6. The index number is 5. Okay. Now see the output. 34. 34 is found at position number 6. Understood? So this is called linear search. Okay, so one more example we can check. Okay, so the same program itself, one more example we can check it. One more example means if the item is not found, what to do? Okay, let's see this. Array is there with the same values, maximum size 10, and 8 elements are there in the array. Location is -1, item is 14 here. Okay, now we are checking with each element. Is it 14 is there in the array or not? So from the 0th position onwards, we want to check it. So 10, is it equal to 14? No. Is it equal to 14? No. Is it equal to 14? No. Is it 18 equal to 14? No. 3 equal to 14? No. 34 equal to 14? No. 56 equal to 14? Sorry. 23 equal to 14? No. Now see, I less than n. So we reached at the end of the element. Is it? Now also location is -1 itself. We didn't get the element. So what to do? If the location is -1, the item is not found in the array. That is the output. See, the item is not found in the array. Location is still in -1. Understood? So this is linear search. Okay. I hope you all understood the concept of linear search. Now in the next video, we can see the second method, binary search method. Okay. So see you all. Bye. Till then, take care.